Okay. Hey everyone, how you doing? It's Brian. It's Friday. It's Rust Day. I guess every day could be Rust Day. But if you're, just a filthy PM like myself, you don't have a lot of time to do Rust work or Rust stations or whatever other culty following they feel like they need to call themselves over here. So it's Friday, so I keep jumping around on programming languages. Rust has so far not been completely horrendous. It's not the programming language's fault. It's mostly mine and some of the tutorials I use. So it's hard to make content, not just written content, but streaming content. So I don't give anybody. What the hell's going on here? I got this thing. It's flashing. I don't know what that is. Nobody ill will. It's just really hard to write, things like documentation or things that are going to be evergreen or be able to ensure that it's going to work in 5 years. So getting things up to date and as quickly as things like programming languages change, you run into issues. So some of the things that I've done in the past that I think have helped screw the pooch is, trying to use whatever up-to-date versions there are versus whatever is mentioned in the owner's manual or the documentation. And so I'm going to attempt to use a tutorial that I found online from 2018 on Rust, which I will put in the chat, because there are multiple chats. I was just poking around for things to do inside of, so there is this person. It is, there we go. Hey, Lady P. You should, what's the tech inside of the space shuttle was? Like 30 years old or something? So I'm actually triple casting this again, but I'm working on things. So for those of you who came in on Tuesday and my audio and video were completely desynced because I had just gotten my brand new face cam, which is right here. About 10 minutes after I got done streaming, I figured out what was up, and so I think I'm good. So the Facecam Pro is great. It does not work on Linux, so I cannot use it in Ubuntu. I spent a good 2 hours today trying to get that to work. The only thing that comes up is I'll get 2 seconds of video, and then all of a sudden, and then that's what happens. I'll go toss you a stream on the YouTubes too. Yeah, I've got several people who had reached out to me and said, "Hey, yeah, this is great. This is great." There's the philop.com is interesting. So I had read through this and I actually started doing some of it because I wanted to make sure that I had the environment set up, because I didn't want to be that person yet again and have nothing done. So we're going to be working through some of that. Yeah, please, Lady P, please feel free to put up the links on the tubes and the YouTubes and what have you. And welcome to all of the people. Hey there, Lady P. From last Tuesday when we had several people rate us, Tigora followed me. Thank you for that. Archaic OW followed us. Thank you. Turtleneck Bandit, Baron Bido, Kale69, X-Ticker, X-Jumox, Taffy OKA. I see what happened there. Mind Killer X, Blue Squadron, Darth Turak, 0x Vania, that's nice. V4NI4, yeah, that's pretty good. Ion the Prize is also followed. So thank you all for coming and hanging out from Al Hazard's group. Shout out to Al Hazard for giving us some love there, and hope you come back and enjoy. So it is September. So September, that was something I saw. Maybe I missed this the last year when I was doing something. Twitch.tv. Breaksec. And I also took some pains to move some things around so it sucks less for the UI. So yeah, here celebrate September, 30% on new subs until October 1. 12 a.m. terms apply, et cetera, et cetera. Looks like you can get a discount if you were to gift a sub or to manage your own sub in here. Also would remind people that you can use your Amazon Prime account for subscriptions if you want to do that. And if you want to gift somebody a sub, maybe somebody who's, looking to get, into InfoSec or, just likes watching, people in the Schadenfreude, you can definitely, invite them to join my stream and, and to subscribe to the VODs and what have you. So, all right. So, you can check out the stream here as well. Oh yeah, there you go. Yeah, it's good call out. I had posted it up on Mastodon as well for that, and I do have the chat open on YouTube as well, so people can poke around and chat on YouTube as well. So, yeah. So, and Discord. If you bang Discord, you can join our Discord. I was actually just having a one-on-one with my boss today, and he said he let me in on a little secret on how, because I remarked, I was like, man, you seem so polished and confident when you're, talking to management, leadership at company events like, monthly business reviews and, operational readiness and things like that. And he's like, I'll let you in on a little secret. I write things down. And I was like, oh, God damn, really? And he's like, yeah, I even write down the little jokes that I'm going to say, or I even have a little thing where I pause. And he's like, it's been very instrumental to, making, I was like, damn. That's next level ish right there. I was like, I didn't say, well, you just seem so confident. Well, I actually did say that, but I was like, it just seemed like you knew exactly what to say, when to say. And he's like, yeah, you're going to find real quick that you're going to have to repeat yourself on many things. Cause I had made a comment in the, in our MBR that, about something that's happening at our org. And he's like, yeah, that's not the last time you're going to have to explain that. So you should probably write that down and maybe polish that up a little bit. And I was like, oh yeah, I've got, I get this, get up here and I'll be like, I'm going to read a statement. So, and he's like, kind of like that, except you want to be a little more natural. And I was like, I understand. That's fair. Yes, Lady P, writing it down. Many people who watch this stream think, wow, Brian is so polished. He must do, it's like, oh, I wonder what would happen if I actually bothered to write down a little script or something to say on stream. He's like, the only thing is you don't want to look, act like you're actually reading something. He's like, you'll want to move around, be a little, a little more animated and whatever. It's like, well, I could just, make multiple copies and put it on different screens or something. He's like, that would kind of work probably. And I was like, I do what I can. So, you see this site up. This is VS Code. What I've done is I've just taken my monitor and I've just split it down the middle. So what you see is on the left, you see my browser, which is on the left, and VS Code, which is on the right. What I've done for more bullet points to remind you. Yeah, to get the high points. I do that with our show notes. To be honest, I do that with our show notes. So if you have an interview, like John Aaron, Megan Arati, the show notes you see in our podcast feed are almost word for word what we put in our Google Docs. So I do have a loose agenda because one of the things I don't want our interviews to come in cold, like some of the other ones that I'm working on right now, trying to get to come in. They kind of would like to have a rough agenda as to what's going on. So what I like to do is give them a little idea as to what to expect. Questions. Especially if it's like I normally get emails from people saying, hey, I'm a PR company. I've got this person. They want to come on and talk about, blockchain. And well, I ignore those. But, if there's somebody, it's like, oh, they're doing something interesting or something that isn't, out of the ordinary. Like the insider investigation stuff, that was based on a PR call. What is this? Okay. Who'd that be? Okay. Let me make sure I can hear the audio coming off of that. And so, I asked for some prepared questions. That way, if something balks, then we'll be able to, catch up on what's going on, or if they want to cover something and I don't know what's going on there, they can give me that kind of answer. So, but yeah, just a little behind the scenes thing there. So yeah, I may end up having to start scripting some of this to make it a little more polished. So, I see you, Beta Wolf. I see you. Anyway, all right, so os.phil-op.com, writing in Rust. I could also put this on white. I don't know. It actually looks better with the dark, so I'm going to go that route. Let me double check my audio just in case. Audio properties. Sometimes OBS doesn't like to play nice. All right. If you're on Beta Wolf, feel free to say something. I'll catch you later. All right. So it says this series of blogs creates a small operating system in Rust programming language. Each post is a small tutorial and creates all needed code. You can follow along if you like. The source code is also available in the corresponding GitHub repo. I did read this, just like the book that I had been trying to follow along. The code does exist in their GitHub, which I have added here. So these are the examples from Philop's BlogOS site. So this is the chapter 1 version, if you would like to have it. yeah, like Lady P says, smash that like, ring that bell, don't forget to subscribe. It's like, right. Wait, if you're seeing me on the screen, it's like right here. Yeah, so it's like, subscribe. You can actually give subs if you want to. So yeah, that's right. Ding, 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 ding. Yeah, there you go. Make it rain, y'all. Because, what we got going on here? Okay. Okay, cool. All right. So, again, I don't know how this is going to go. But I wanted to do something that actually would be kind of fun. I did want to create the next Flappy Birds because, that's the only way to make money around here, in the internets, is to have something that goes completely viral and it's the new hotness for about 20 minutes. Cash in on it as much as you can, and then it gets thrown off in the dumpster. Whoa, look at that. Thank you all so much. Appreciate the love there, Lady P. And so, oh, that's lovely. You're coming in a little on the side there. Yeah. Relentless size sack. Okay, let's turn that down a little bit, huh? Yeah, there we go. Well, we'll see what's going on with SciSac. Anyway, all right. So, if it gets too weird, I will probably end up just having to kill the Discord channel. So, all right. So the first thing they want to do is they want to create a freestanding Rust binary. My guess is that we're going to create the binary and then build upon that into what's like a full-fledged kernel. The other thing I liked about this idea is you don't start off writing Rust code that is, import 800 dependencies, which I was not a fan of, anything that we're building, because it's kind of like you want to know what the ingredients are there in the you know what? Let's not tempt fate. I'll just go ahead and drop the Discord. You kind of like to know how the eggs are made. The eggs are made and the cake is made, and importing a bunch of packages is like, okay, yeah, it's super easy to do this because somebody else has really done the work for you. So the one thing I found from this is we're going to start with no packages, no modules, no nothing. And so this person goes on to start about, to write an operating system kernel, we need code that does not depend on any operating system features. This means we can't use threads, files, heap memory, the network, random numbers, standard output, or any other features requiring OS abstractions or specific hardware. That's fair, which makes sense. We're trying to write our own OS and our own drivers. Now, if I get to the point where I'm writing my own Rust drivers, I better be making fat loot, that kind of thing. So I'll hang up being a PM and just, work myself as a contractor or something. It says this means we can't use most of the Rust standard library. So there's a standard library, I guess, that is called by Rust. And they say there are a lot of Rust features we can use without using the standard Rust library. For example, we can use iterators, closures, pattern matching, option and result, string formatting, and of course the ownership system. These features make it possible to write a kernel in a very expressive, high-level way without worrying about undefined behavior or memory safety. In order to create an OS kernel in Rust, we need to create an executable that can be run without an underlying operating system. Such an executable is often called a freestanding or bare metal executable. Seems like there'd be more freestanding executables, but thank you for the bits, Lady P. I don't get a lot of bits, so that's kind of interesting. I'll have to see what that ends up being. Let me post that link here. And all right. So let's see. This post describes some necessary steps to create a freestanding Rust binary and explains why the steps are needed. If you're interested in a minimal example, you can just jump to the summary. Very cool. Cup of coffee with creamer. Oh, okay. Well, that's good. Is it the good creamer, Age of Music, or is it like the really garbage creamer like International Delights or something like that? Penny a bit? That's not bad. That's not bad. All right, so disabling the standard library. So obviously, like they said, you can't have anything that requires an OS, because if you're going from bare metal to, a prompt, you're going to have to start with nothing. So I created a new cargo application. Oh, damn your hide! Come on now. There we go. Let's bang this up a little bit. There we go. All right. So as you can see, what I did here, I didn't, because they show you. So let me open this up here. There is a 2022 version of this, or 2021 version of this. So they have a 2015 Rust edition, a 2018 Rust edition, and a 2021 Rust edition. Wait a sec. There we go. So yeah, they have a... Oh, thank you, Relentless Sisek. Sorry the audio thing isn't working. I don't know why you were coming in all staticky on your Discord. So on the Discord, I don't know why that was working like that. International Delights. Oh, that's good. I read the label on those International Delights. There's not a lot of actual cream in them. So, but yeah, so Rust 2021 is available. Of course, this was written in 2018 when this person didn't know that 2021 was coming. So there are some things that it might be a little different if you try to do this without following the instructions. And one of the things that has bit me in the ass previously with other programming language stuff is I'd like, oh no, I want to use an updated version of Rust, and I want to use an updated version of Go, and I want to use an updated version of Python. And because can't seem to find stuff that was written this year because, it is in flux, I'm going to stick with the 2018 version. So if you're like, oh, this is all changed, this is not new Rust, then that's why. So there you go. Yes, yes, thank you, Age of Music. I understand it is non-dairy. I like my milk fresh from the teat, if you will. So yeah, it makes sense. So what they do is they fill. I'm gonna assume Phil op is going to create a new cargo application project. The easiest way of doing that is to go cargo new blog OS bin edition 2018. So it sets a larger version above. So anything, anything 2019 pandemic Rust, up to today, not going to be included. I did that here. I created in our Rust OS, in our Rust folder, the Rust OS subfolder, and then the blog OS. This may end up biting me in the ass too. I don't know. We'll figure it out. But under the Rust OS, there was a blog OS. So I'm not sure why they did that. But so I have a directory called My Drive, GitHub Projects, Rust, Rust OS, Blog OS, and then I did the. So I ran that command right there. And that created my directory structure under rust/blog OS. So here's my main.source. Here's my cargo.toml, which is my configuration file. It's empty right now, except for the package blog OS 0.1.0 and 2018. And then there's the definitions link. There's no dependencies whatsoever. And so I did an ls. Obviously, you can see the directories here. And then I added in my main RS, because I was trying to go down here a little bit. It says we're not going to use the standard Rust library. So they ask you to put in no standard attributes. So I added that here and added the comment line here, / is main RS. That's just main RS. I added the no standard, and then I tried to run it, and then the error occurs, which is actually correct here because we cannot find macro println in this scope. So that's cool. Person says the reason for this is that the println macro is part of the standard library. So we have to create our own println, and we have to create our own, and as we find out, we're going to be having to create our own things, right? We're going to have to create our own error handling. We're going to have to do all that stuff, as you see as we scroll down here. So we can no longer print things. So right now, with no standard Rust library, which is, it seems like it's an understood thing, right? So if you create a main.rs, it automatically imports std, right? Or std.io or whatever. I think when we were doing Go, I think std.io was one of those things. But since we don't have that ability, we're going to be putting those in. This is a good reference, silly embedded bits. Okay, excellent. Thank you, Relentless Sysec. Appreciate that. Rust docs embedded org, I think. No, not the embedded org stuff. Let me go click on that. What do we got here? Embedded Rust book. Okay, the embedded Rust book, introductory book about the Rust programming language on bare metal systems such as microcontrollers. Yeah, I'm not doing microcontrollers, but we'll keep this in mind here. Are you using the libc crate? I'm using whatever the person on the blog post said to use. So I can't give you a better answer than that because I don't know. I mean, what you see here is what you're getting. So, yes. It's like, wait. Oh, I'm my own emoji now. So yeah, I'm assuming it's going to use whatever the crate is. So, I have added no standard, no println. It says the reason for this error doesn't exist. Let's remove the printing and try again with an empty main func. Okay, so we're going to remove println, hello world, and then we're going to Control S to save, and then we're going to try building this bad boy again. Okay, and it says now the compiler is missing a panic handler function and a language item. So that's those right there. And panic handler attribute defines the function that the compiler should invoke when a panic occurs. Okay, so it can't even say, I don't know what to do. I'm panicking. I don't know what to do. So we have to add some conditional statements in to say, okay, this is what we're going to do. But in a no std environment, we need to define it ourselves. So this is in main rs. So I'm assuming, actually, let's not assume because that's how I get screwed up anyway. So we are going to go to source. We're going to go to main rs, And okay, so you can see this is the summary at the end of chapter 1, or the binary. This is what our screens should look like at the end of the freestanding binary bit that exists. So you can see they put it right after well, at some point we'll put in no main, so we'll also need to put in use core panic info. Again, this may not be the best way to do it, and it may not be the most secure way of doing it. If anybody has any thoughts on that, we'll have to see, because the last thing is going to happen, I'm going to get PC load letter, and then I'm going to be like, I don't know what to do. Hey, guy, person who, suggested this, what do we do? And then they're gone. So if you have an idea on the better way to do it, put it in our Discord. That way I can look at it later instead of trying to figure that out on stream, because I love me some flailing during my stream, I tell you. All right, so use core panic info. All right, so we'll do that, and then it says this function is called on panic. So we're going to create a panic handler, which... Okay, so it's interesting. They put this at the very bottom of the doc instead of like right after the use core panic info. I'm sure there's a reason for that. I don't. Okay. This function is called on panic. So we're creating a function called panic handler, because the idea is once something goes pear-shaped, we need to be able to guide it to tell it what to do. So we're going to go function panic underscore info ampersand panic info, and then like exclamation points, and then bang. Relentless. How would I find out if I was using the libc crate? That's a good question. It's always good to know that kind of stuff, because they're not the person who wrote this did not TOML. Okay. Let's go look in the cargo TOML. That's it right there. That's all I've got. So when I ran the command up here for blog bin edition 2018, that's what got created. So I would say no if it doesn't say it. So, but if you do not put it in manually, it won't be. Okay, there you go. So I did not make the suggestion, so it's in there like that. So. All right, so loop. All right, we're done there. All right, so the panic info parameter contains the file and line where the panic happened and the optional panic message. Function should never return, so it is marked as a diverging function by returning the never type bang or exclamation point. There's not much we can do in this function for now, so we just loop indefinitely. Looping indefinitely does not sound like a good idea, but I did not write this. So until we get a better idea of what's going on there, we'll figure it out. So the personality language type, it's almost like the meh personality. Language items are special functions and types that are required internally by the compiler. For example, the copy trait is a language item that tells the compiler which types have copy semantics. When we look at the implementation, we see it has the special lang equals copy attribute that defines it as a language item. While providing custom implementations of language items is possible, it should only be done as a last resort. The reason is that language items are highly unstable implementation details and not even type checked. Okay, so the whole idea of using Rust is things like stability and type checking and memory safe functions and things like that, and using this haphazardly gets rid of at least two of your three items of why you would use Rust in the first place. So the compiler doesn't even check a function has the right argument types. Fortunately, there's a more stable way to fix the above language error item. or item error. The personality language item marks a function used for implementing stack unwinding. Stack unwinding. I don't know what that is. We're going to unwind the stack. It's a C++ thing, looks like. Okay. Stack frames. Control F, unwinding. Okay. Adding a subroutine's entry to the call stack is sometimes called winding. Removing the entries is called unwinding. I wonder if that's similar like a, what is that, pop and push and pop or something like in Python. Yeah, okay. Cool. Let's add that just so people have it. All right. There we go. Now let's close some stuff as we go along to try to prune the love here. All right, so disabling unwinding. So we're not wanting to unwind anything. There are use cases as well for which unbinding is undesirable, so Rust provides an option to abort on panic instead. This disables the generation of unwinding symbol information and thus considerably reduces binary size. There are multiple places where we can disable unwinding. The easiest way is to add the following lines to our cargo.toml file. Profile.dev, panic equal abort, profile.release, panic equals abort. All right, so Oh, I see. All right, yeah. So let me back up a bit. Go to BlogOS. Let's go see where in the cargo toml they put that. I'm assuming it's under dependencies, but okay. So yeah, we've got profile dev. All right, panic equals abort. All right. In C++, when you toss an exception, the function call stack is searched in a linear fashion to your exception handler, and then all entries before the exception handler function are removed from the function call stack. There you go. Lady P dropping some knowledge on us. Yeah, I'm finding, yeah. Okay. Panic abort. Okay, there we go. All right, and also always remember to Control S and save your stuff. Obviously, we'll commit it up at some point in the future once I get everything running. So go BlogOS, go back to source, go back to our main RS. All right, so that's the only change we're going to make to cargo.toml right now that I can see. All right. So this is kind of like a low-level question implementation. Yes? I don't know what the question is. This is this makes a little more sense if you have some assembly language or machine language experience. We're talking about stat calls. Right. So right now, if you remove the standard library, my guess is there's no way to address the issues as they come up, which is why we're adding things like being able to handle errors right now, because right now there's no way for it to handle errors. So it's going to run into problems. So as a matter of fact, it says down here, this can occur with a binary crate with no standard is compiled for a target where personality is defined in the standard library. So that's pretty cool that they were able to give you, that's a more verbose error message than I saw in my previous discussions with the game stuff. So it says you may be able to compile for a target that doesn't need it by specifying -- target or in cargo config. So, and then we had 3 errors. So no println, no panic handler, and no personality thing. Must stand for something. So we'll see. All right. So this says, okay, now that we fix the errors, however, we try to compile now, yet another error occurs. Cargo build error requires start lang item. I'm actually just heartened by the fact that I'm doing something and it's giving me the errors, and then I go over and look in the book or blog post here, and I'm seeing those same errors. So I'm just happy about that. So okay, so panic handler function required but not found. Uh-oh. No. Okay, error. Yeah, 1 second. Oh, right, I didn't save it. There we go. There we go. All right, let's try this again. There we go. Oh, God. Oh, this is going to be a long day. It's going to be a long day. Let's see. Warning, failed to garbage collect incremental compilation directory. Oh, there we go. Okay, core panic info. Oh, that's why. There we go. All right. There we go. Okay. Something as simple as, sorry, I don't have any low-level experience with Rust, so I can't tell you how it's handling its stack. That's okay. I don't have any low-level experience with Rust either, so I can't tell you how it's handling stack. Lady P and I are finally on the same footing, so that's great. No, it's not. Yeah, so I screwed up. Sometimes I wonder if I have dyslexia or something, or I can't recognize camel case or something. So not having a capital I here threw up all those additional errors, which I was starting to freak out and get ass sweat. So it's better now. Just having panic info and saving it properly gives me the right error message that we were having issues with. So, all right, Lady P, I'll cede that point to you. Okay, you know a little bit about stack handling. All right. Yeah. And I'm being completely facetious here. Lady P can run circles around me on pretty much anything tech. So it's a jokey joke between friends. So, all right. So panic info parameter. All right. So our program is missing the start language item, which defines the entry point. You might think the main func is the first function you call when you run a program. However, most languages have a runtime system, which is responsible for things such as garbage collection or software threads like Go routines and Go. This runtime needs to be called before main since it needs to initialize itself. So we got func main right here. We've seen func main quite a few times in Go and in Python and MC, and Rust is no different. In a typical Rust binary, that links the standard library execution starts in a C runtime library called CRT0. So it's interesting. We're seeing a lot of this. This person has the deep knowledge, at least, on how things work, because you don't see this stuff because it's really really deep knowledge here. So we're looking behind and at what Rust actually does without us knowing. Like, there's a bunch of stuff that gets called as a module or, in the standard library that, we just take for granted, I think, which sets up the environment for a C application. This includes creating a stack and placing the arguments in the right registers. C runtime then invokes the entry point of the Rust runtime, which is marked by the start language item. So this creates the where to put memory. Well, this is, it's going to use hopefully a random value, but it's going to use a spot in memory, and this is where the start language item is. That's what I'm understanding. Rust only has a very minimal runtime, which takes care of some small things such as setting up Stack Overflow guards or printing a backtrace on panic. The runtime then finally calls the main function. Our freestanding executable does not have access to the Rust runtime and CRT0, so we would need to define our own entry point. Implementing the start language item wouldn't help since it would require CRT0. Instead, we need to overwrite CRT0 entry point directly. Overwriting the entry point to tell the Rust compiler we don't want to use the normal entry point chain. We add basically no main attribute. So we're going to create a no main line here. and then you might notice that we removed the main function. Okay, so, well, yeah, because no main means we're not going to have a main function. So there's no reason to have a main function if you're not going to have main. It'll probably actually error, I would imagine, during the fix. Relentless says, use the box type a lot to manually handle stack. Rust docs, stable Rust by example, std box.html, but I think this is still in std. Okay. Very good. Oh, right. Maybe my render times would go down if I didn't have things clicked. There we go. Yeah, I'm learning more and more about OBS every day. Like clicking on an element inside of the overlay actually adds about 3 to 5 milliseconds of render time for some reason. Unclicking it goes down. I know 2 milliseconds is not a huge deal, but it's like I'm just seeing things change as they go along. So yeah, there we go. It's probably easier. I'm curious how your OS is going to handle secure boot, so I'm watching curiously. Yeah, not to derail the conversation because I'm about to. I was looking on Amazon for, like I did with this machine, a gaming PC, so to speak. And all of them come with Windows 10 for some reason. And I was like, I wonder why that is. I don't know why yet. My guess is it's because Windows 10 is more stable, or that Windows 10 licenses are way more cheaper than Windows 11. Everything that had Windows 11 at least home in it was always $100 to $200 more expensive, which is kind of funny because I guess they're paying for the Windows 11 license or the Windows 11 home license. My thought was on Amazon, especially if you're a streamer or you want to play the games that come with that only work on Windows, those gaming PCs are going to get cheaper in the next, say, 6 to 12 months, because if they don't run Windows 11, people are going to buy them, and then Windows 10 is no longer going to get updates. That's going to cause some consternation. Yeah, well, I mean, we tried, Lady P, you remember we tried putting 11 on this box, and I got hypervisor errors and blue screens during the stream. So I was very unhappy about that. So I'm just kind of hedging my bets, and I'm looking for something right now that would support Windows 11, because I tried running Ubuntu, and like I said, the last couple cameras I had issues with and audio issues, and I'm like, Linux isn't worth my time and effort right now for that. If I want to do that, then I'll figure out how to hook my laptop up, which is running Ubuntu, and then I'll show the screen on the overlay, and because I've got capture cards and stuff that I can use for that. So, anywho. Yeah, so, I mean, we're going to not have any more feature updates after this month on Windows 10, and we'll only get security updates until 2025, and then after that, no more updates. So, depending on how important updates are to you, security or otherwise, you'll be moving to Windows 11 Home or Linux. So, all right, so you might notice we removed func main. The reason that a main doesn't make sense without an underlying runtime that calls it. Right, exactly. Instead, we're now overriding the operating system entry point with our own start function. So we'll have no mangle. Let me make sure I've got all my stuff saved here. There we go. Go back to main RS, which is our main function here. I remember correctly, so if I remember, so we'll need to put no mangle here. I think I posted this up on Mastodon, and I said, can you really make a complete OS with Rust? And I said, somebody seems to think they can. I'm done with Windows after 10. I only have a couple things that stupidly insist upon Windows. Most everything is running fine on Linux. I just have to have my gaming machine on 10. Yeah, I don't know. It is possible to do it on Linux. The problem is, at that point, we're going back to like 1999 when I'm having to, I'm using OpenBSD and I have to go, oh, well, is there a driver support for it in Linux? Oh, I can't buy that one. I'm going to have to buy something that's 5 years old and gives me, 720p 30 frame rate range and stuff like that, and it's like I have to go works with Linux or something like that. Is there driver support for this? Oh, well, there is an Arch but not Ubuntu, or there is in Fedora but not Arch, or God forbid Slackware or something like that, and it's like, oh my god, I don't want to have to deal with that garbage. So Some people do. I mean, my laptop works great. The webcam in it works great for Lenovo. I mean, if I don't want to use the nice face cam here or my DSLR, I could use my POS laptop camera in a pinch. It works great. And actually, the Shure mic that I have works great on Ubuntu for that. But it's like, it's the laptop cam, you know? So, yeah, anyway. Start. And then we're going to have our redirector to never, or bang in this case. And then loop. There we go. So it looks very similar to down here under the panic handler where we have a func, panic, info, and then we had a loop down here too. So by using the no mangle attribute, we disable name mangling. That's a new one for me. Name mangling is a technique used to solve various problems caused by the needs to resolve unique names for programming entities in many programming languages. Oh, yeah. I think I saw something earlier like that where I had got it wrong. Let me see. Where did it say? Because I'd gotten... I typed something differently. Yeah, similar. Yeah, see, help. Similar name exists with the module panic info. Yeah, so the mangling bit. So I did not have a capital I instead of panic info. So it told me, hey, a similar name exists with this module. Maybe instead of going, hey, did you hi, I'm Clippy. Did you perhaps mean this one instead of this one? So there's no autocorrect in VS Code yet. Or Copilot. I'm not using Copilot or anything like that. So, oh wait, Control S, not Control F. All right, and so close that. All right, so no mangle. Without the attribute, the compiler would generate some cryptic value or symbol to give every function a unique name. Okay. I wonder what would happen if it used cdecl. C declaration, I'm assuming, of some kind. Except now GPUs are supported on Linux first. Yeah, Lady P, you know what? My when I was using Ubuntu 18, it was like I had to go to NVIDIA's site and pull down the right proprietary drivers because it wouldn't load them. And then it's like now it's like, oh, all of a sudden everything works. And so, yeah, instead of standard call. I do not know. That would be an interesting question I will do after I finish the chapter to see. So yeah, so if you without the attribute, the compiler would generate some cryptic, so it would create this kind of weird symbol because it's a random enough symbol to give every function. The attribute's required because we need to tell the name of the entry point function to the linker in the next step. We also have to mark the function as an extern C to tell the compiler it should use the C calling convention for this function instead of the unspecified Rust calling convention. Okay, I did not know that there was a difference. It's not hard to believe. In C++, oftentimes you don't want name mangling, so you use extern C linkage specifier in the declaration. Okay. A calling convention is an implementation low-level scheme for how subroutines or functions receive parameters from their caller and how they return a result. Okay. Very good. I'm learning so much. Okay. I'm going to have to... I've got some stuff to read. So... No, it's okay, Lady P. I'm glad you beat me to it. So far, with Lady P's help and with some very helpful stuff, I don't want to oversell this, and I don't want to get too hopeful that this is actually going to work when I'm done with all of this stuff. But yeah, so cautiously optimistic. All right, so the bang means that the function is diverging, not ever allowed to return. This is required because the entry point is not called by any function, but invoked directly by the operating system or bootloader. Instead of returning, the entry point should invoke the exit system call of the operating system. In our case, shutting down the machine could be a reasonable action since there's nothing left to do if freestanding binary returns. For now, we fulfill the requirement by looping endlessly. So it'll just pretty much hang at this point. It'll just sit and wait. I'd imagine we could maybe do a Control C at some point, but I mean, this is like the kernel, so nothing happens, right? When we run cargo, now we get an ugly linker error. It's not that the link is ugly. It's just the error looks ugly. So brace yourselves. Oh goodness. That is, okay, I see the ugly linker error now, yeah. And it says, note link fatal error LNK 1561 entry point must be defined. And then we got this big long old path. It looks like it's looking in our path for something. So interrupt 21 call probably like 21 comma 0. Okay. Linking with link.exe failed. Exit code 1561. Let's go see exit code 1561. Okay. Oh, let's do Rust as a matter of fact as well. So there we go. Link entry point must be defined. So yeah. Yep, I got that error message. Look at that. Yeah. Okay. Did someone manage to make no stid work with Win32 target? Now, this one did say it was a 64-bit OS with x86. Oh, my goodness. Hello, Sakura95. Thank you for joining. Thank you for being here. So this is a 64-bit OS. That is one thing that the book did mention, that we'll be doing 64-bit because, all the bits, right? All right. The linker is a program that combines generated code into an executable. Since the executable format differs between Linux, Windows, and Mac OS, each system has its own linker that throws a different error. The fundamental cause of the errors is the same. The default configuration of the linker assumes that our program depends on the C runtime, which it does not. To solve the errors, we need to tell the linker it should not include C runtime. We can do this either by passing a certain set of arguments to the linker or by building a bare metal target. All right. And building a bare metal target. Rust tries to build an executable is able to run in your current system. For example, if you're on x86-64, Rust tries to build an exe that uses x64 or x86-64 instructions. This environment is called your host system. To describe different environments, Rust uses a string called a target triple. Okay, you can see the target triple for your host by running rust c version verbose. Rust c a version of verbose. Okay, and you see it right down here. Rust is the binary commit hash. This is the commit hash we're using. Commit date, July 12th, 2023. Host x86-64, version 171.0. LLVM version 1605. Okay, so my version is quite a bit different than his, or Phil's in this case. Phil could be Philomena for all I know. Anyway, so... yeah, the above output is from Linux system. Okay. Oh, right, because host is unknown GNU Linux. Mine is PC, Windows, MSVC. We see that the host triple is x64 or x86-64 unknown Linux GNU, which includes the CPU architecture. x86-64, the vendor is unknown. Okay. And the operating system Linux and the ABI GNU. Okay, so that would mean ours is x86, the vendor is a PC, operating system is Windows, and the ABI is MSVC, which I'm assuming is Microsoft's Visual Code. We'll see. Rust developers coding the entire known universe in Rust. Yes, Sakura. Sometimes we just like to push that boulder uphill, and I ain't even a Rust developer, so it's like Rust person doesn't know anything trying to code the entire known universe in Rust. What? Oh my goodness. Well, why don't you get up here? Well, we can have another one-on-one. It's fine. Yeah, there you go. Okay. All right. Shh. Hush. I know. It's fine. Okay, it's fine. It's fine. An example of such a bare metal environment is the Thumb V7M. All right. The example of a bare metal environment is the Thumb V7EM None EABIHF target triple, which describes an embedded ARM system. The details are not important. All that matters is the triple target has no underlying operating system, which is indicated by the none in the target triple. Okay. To compile for this target, we need to add in rustup. We're going to add rustup add. All right, so we're just going to do that because I don't want to try to type this wrong, and I'm using a mouse hand right now because I have somebody with me. So you're a pain in the butt. You know that? You are. You're a booger. You're a booger. Copy. There we go. All right, you see I put the rustup target add, and then have you ever tried GNU and Linux? I have tried Linux and GNU. Oh, okay. I shall hydrate. Do you want some? No? Okay, that's fine. It's just water. It's just water. All right. This downloads a copy of the standard and core library for the system. We can now build our freestanding executable for this target. Cargo build target, and then we're going to use this specific target. Okay, so let's do that. Here we go. You see we've got the build target down here. Let me double check and see what's up. Yep, okay. Oh, yeah, let me just kind of move that out of the way right there so you can see what I put in there. I added the target type, what have you. There we go. All right, so we're going to hit enter. Oh my God, it's working. I think it worked. Oh my goodness. Things worked. Isn't that awesome? We had talk time earlier today, so one-on-ones. So all right, so by passing a target argument, we cross-compile our executables for a bare metal target system. Since the target system has no operating system, the linker does not try to link the C runtime, and our build succeeds without any linker errors. This is the approach that we will use for building our OS kernel. Instead of Thumb V7M None EABA whatever, we will use a custom target that describes x86 bare metal environment. The details will be explained in the next post. Linker arguments. Instead of compiling for a bare metal system, it's also possible to resolve linker errors by passing a certain set of arguments to the linker. This isn't the approach that we... What? This isn't the approach that we will use for our kernel. Therefore, this section is optional and only provided for completeness. Click on linker arguments to show the optional content. Sakura, most distros are GNU anyways. I use a custom-made distro of Linux that is somehow what I now refer to as transkernel because it identifies as Kali for whatever reason, presumably because the packages for Kali are pre-installed. Yeah, I mean, it's it allows for I'm surprised you didn't say it's a custom version of Gentoo because people just like pain, I think, at least when using Gentoo. Let's see if this is... Oh, okay. So this area, the linker arguments does expand out. So it says in this section we discuss the linker errors that occur on Linux, Windows, and Mac OS and explain how to solve them by passing additional arguments to the linker. Are you done? Psst. You're a pain in the butt. Note the executable format and linker differ between operating systems, so a different set of arguments is required for each system. Okay. On Linux, the following linker error would occur. Linking with CC failed exit code 1. Okay, so... Oh, see, Relentless, I thought we were going to be able to be friends. Oh, it's too bad. Custom Arch, yeah. Yeah, it's been a minute since I tried to use Gentoo. I got to, I think, I used to use OpenBSD, so you got caught, Relentless. Yeah. I'm sure they all have their I'm sure they have their likes and dislikes from Linux. And I'm not here to get into thank you, Lady P. Linux is, I think it would have gotten far more adoption if everybody didn't create like 500 versions of that. It is what it is. There's no holy wars. People like them some Arch, Gentoo, Slackware, Fedora, CentOS, Elementary. It is what it is. And there's some people that swear by it. I've tried numerous different Linux versions so far, and it works as a daily driver, but until I actually try to do something with it, like streaming, there's some problems. Alma Linux, Mint, right? Exactly, Mint. I actually looked into Mint. Alpine, I like Alpine as well. That's what all the Kubernetes stuff runs on. There's a ton of stuff. Oh, Relentless, right on. I grew up on VI, so I never got into Emacs or Nano. So, yeah. Anywho, one way to pass linker attributes via cargo is the rustc command, cargo rustc. The command behaves exactly like cargo build, but allows you to pass options to rustc, the underlying Rust compiler. Okay. So compiler flags like if you, I don't know, can you do a strict or something like that? So if you wanted to see, or verbose, where you wanted to see all the errors that are coming up or all the warning messages, rustc has the c link arg flag, which passes an argument to the linker. Combined, our new build looks like this. So it would be cargo rustc ---- link arg no start files. Now create builds as a freestanding executable on Linux. Oh, please don't bork my system. If this don't work, I wouldn't be surprised. Yeah, see, we got a linker issue there. We got the 1561 linker issue. So because I tried to build it on Linux on Windows, I guess. Now our create builds is a freestanding executable there. We didn't need to specify a name on our entry point function explicitly since the linker looks for a function with the name start by default. On Windows, a different linker error occurs. We got the 1561 error issue. Entry point must be defined. So you can, instead we can pass an entry to the linker. Oh, we got an error there too. Huh. Now a different error happens. So, link.exe. So yeah, note program files x86, or in this case, program files, and then Visual Studio link.exe right there. Fatal error link 21 or 1221. Subsystem can't be inferred and must be defined, right? This error occurs because Windows executables use different subsystems. So if we use this, it should work. No, you rat bastard. You are a rat bastard. Link.exe is possibly the least suspicious file name I've ever heard. That is very true, Sakura, yes. There we go. Oh, there we go. See, unoptimized. There you go. 1.38 seconds. Nice. My personal server runs in Ubuntu. I had to use Nano because it was pre-installed. I ended up having to fix a ton of packages because Wi-Fi Epsteined itself mid-update. So basically, I had to tell the kernel to live update itself so it wouldn't hang on to a memory error. Yep. I do. If you do a bang Discord, you can find our Discord. We do have rules and info, a social contract. We are moderated. Lady P also will follow you over there if you would like to, there you go. We do have standards of behavior as well. So yeah. I paid for a level 3 boost on Discord for quite a while, so that's how I get my vanity plate. Besides, nobody had BreakSec. It's all BREAK, not BRAKE. So, Oh, that's as official as it can be. That's mine. So I've had BreakSec for about a decade from podcasting and streaming and twitching, and yeah, my last name is Brake, Brake. So as a matter of fact, it was for the longest time. We used Breaking Down Security, but too many people were like, "You spelled breaking wrong," and then it was like, "That's the joke." And I pooched it. If I could go and tell 10 years ago me, "Hey, don't do that because people are stupid and they'll be literal." I'm just dead, Lady P. Got me. Damn it, Lady P. Yeah. Anyway, so we have linkers. We're not going to try the OS one because obviously I don't have Mac OS. You can unify the builds, I guess, by putting this in Cargo Toml, so you can actually build 3 different kinds of, I would imagine you'd want to put this in if you're actually building an OS, and you, depending on the host platform, which is not ideal. To avoid this, we can create a file named Cargo Toml, which contains platform-specific arguments. Rust flags key contains arguments that are automatically added at every invocation of rustc. For more information on Cargo Toml, check out the official docs. Now that our program should be buildable on all 3 platforms with the simple cargo build command. All right, well, I will add these to the Cargo Toml file. What's the worst that could happen? We'll see. There we go. So ideally, it'll come in here and go, oh, okay, I see that this is a link, or this is a Windows, or a Unix, or this is a Windows, or this is a Mac OS. And so I just do cargo build. Oh, I still got the error message. That was interesting. Okay. See, yeah, with a simple cargo build. Did I miss something? Maybe I didn't. I mean, the fact that it runs. Oh, yeah, I'm not. Yeah, so there we go. At least we know that it builds that way. So it says failed garbage collect. I did see these errors before. Unfortunately, I dorked it up again. Google Drive does something weird with its file system kind of thing. So these warning messages are not indicative of what will happen if you actually built this locally on your box and used GitHub properly. So, well, so Sakura, it builds, so, it works on my machine. So I'll just, ship it. So, yeah. So it's it is what it is. The hard linking of files, Google Drive doesn't allow for hard linking, so that's probably why it's coming up with those kinds of issues. So minimal freestanding Rust binary looks like this. So we have main RS. Exactly, Sakura. That's the meme. Yes, it works fine on my box. I don't know what the hell is wrong with y'all. So, yeah, exactly. Oh. It was really weird. I got 34 frames a second right there. Let me turn off the preview to make things a little easier. I was getting a little drag there for some reason. All right, so here's the summary. No standard, so don't link the Rust standard library. No main, so disable all entry points. No func main in this case. Use panic info because we have to do error handling, and it needs to know how to panic properly. Otherwise, it's just going to do nothing. I don't know. Seems a little, unneeded because it's going to panic. It doesn't know how to panic properly. So we add the panic handler at the bottom here under panic handler. And then we don't want to mangle the name of the function, so we don't want a func main because we don't want an entry point. So this is how we create the entry point in the system. So underscore start. And ideally, then it picks someplace at random. I'm hoping it's random. What I'm wondering about is if you took 2 machines that were exactly the same and ran this kernel in bare metal, would it inject it into the same memory? My guess is no, but that would be something you'd want to test from a security point of view, because you see that with a lot of, like somebody mentioned, embedded systems earlier. Lady P, you don't need to teach you how to panic properly. I already can panic properly for both of us. So, but yeah, way back in the day, you hear about certain systems or gathering entropy for things like SSH keys or whatever, and it's like if you have two exact same systems, how are you creating randomness? And if they're exactly the same and they start up at the exact same time, will those keys be the same or will they be similar or whatever? So I'm assuming that there is something that will make it inject into a random spot in memory. Sakura, honestly, I'm off. I just joined solely to make that rest joke. Be honest, you're a really good streamer. Oh, well, thank you, Sakura. That makes... You should have checked me out on Tuesday. Thank you so much. I appreciate the positive comments there, and thank you for coming and joining us. Feel free to come back again if you want to talk about security stuff. At some point, I'll be getting into some gaming items when I can, not get over the imposter syndrome. But yeah, it's crazy that a whole industry was born for doing this on blockchain, probably based on UUID randomization. Yeah. Because, people will be like, oh, well, we'll just do it based on time or seconds or milliseconds or whatever. And it's like, no, because that's determinable, right? You can guess. Okay, in 10 seconds, this will be the key, or in 20 seconds, this will be the key. So, yeah, you have to have some kind of form of entropy that, is random enough or, something that can be easily determined, right? Lady P is about to correct me. I feel it. I can feel it. My ass started sweating again, so. Great. Anyway. Well, that feels good. I'm getting all warm, fuzzy feeling. What is this feeling when people tell you nice things about yourself? It's really weird. Anyway. All right, so here's your Kagro.toml, which matches what we've got here. Actually, you know what? To feel better, I'm going to go ahead and... Oh, you know what? I didn't save that, did I? That may be why it didn't work. Cargo build. Nope. Still errored. All right. Well, I'm going to remove that because I don't want to have any issues later on. Could you possibly DM me on Discord and help my Python thing initialize because it never passed through a init because I don't know, man. It's also maybe it's either hardware ID based and then. So Sakura, I would just say hit us up on Discord. I didn't name my firstborn Python, but if you've got an error message or something that we can help you Google through, or if you want to put the code up, if it's IP or business for your work, maybe don't do that. But we can definitely work through some of those items. But yeah, when I say that I've done some Python and I've done some Go. Python was a long time ago. Go has been more recent, but I have less, experience with that. And Rust, I'm learning as I go along. But, there's numerous people on our Discord that could probably help you out as long as it's some kind of pet project and not business IP related or like super secret squirrel stuff. Yeah, we have a lot of actual programmers on Discord. Somebody far smarter than me, Lady P. So, well, we posted it up already, Sakura. If you go bang Discord. There you go. Discord.gg/breaksec and then follow the instructions. All right. So we're not going to build the binaries. We already built it on Windows, and that's the only one we need. Note, this is just a minimal example of our freestanding REST library. This binary expects various things. For example, that a stack is initialized when start function is called. So for any real use of such a binary, more steps are required. Oh, crap. Really? Okay. The next post. Oh, I'm Berber Prime. Yeah, sorry, my bad. Yeah, I'm Berber Prime on there. So, I'm double alliterative because Brian, break. So the next post explains the steps needed to turn our freestanding into a minimal system. So let us go. I'm doing okay, an hour and 15 minutes, and I haven't broke anything yet. All right, so as of February 10, 2018, when Phil Opp wrote this, this was functional. So post O2 branch. So we're going to go look at, no. Okay, Phil, if that's your real name. So this is the O2 branch, which is going to build on the O1 branch. Oh, I can't type. That's probably good. I probably should remove that. There we go. And then there we go. Yes, Lady P is one of our mods. Scott Pack, you can check him out. He's also awesome. One of our moderators. We have, we always love more people on Discord, and if you find value from our Discord as well, and you don't want to support us on Twitch, you can, pop a boost or nitro boost in there or something. That'll be good. Relentless. Please, feel free to join. Yeah, I love that. Just remember to follow the instructions. We don't tend to give a lot of warnings if you are a bad person because we expect everybody to act professionally in our Discords. So, all right. It's all based on mutual respect, something that is a bit of a lost art these days. All right. So here's our main.rs. This is what our kernel will look like at the end of the chapter. Oh, hey, Jake. Hey. Yeah, we don't toss a lot of people either because we, so far we haven't had to boot too many folks. All right, so minimal Rust kernel, y'all. All right, so here's table of contents. Boot process. Oh, wow, we're going to get into the UEFI stuff. BIOS, if you have a box from, the 2020, early 2010s. Minimal kernel, running the kernel. Wow, this may be a fairly long chapter. Okay, so it is a fairly long chapter. So we may get through all of this, we may not. It is not 2240. It is, only 330. Okay. 1 second. I know it's the weekend before a holiday, but people like to throw curveballs at me at the last second. I'm glad people came by on a Friday. I know most folks are trying to haul ass out of town for the last summer holiday. So what do we got going on here? Yeah, I've got some stuff going on at work next week on our short week that I want to make sure that we're staying up on. Get the fuck out the way. Oh, there it is. Okay. I did get a direct message. Okay. Oh, gods, really? Fine. Whatever. That works for me. Nobody tried to set up a meeting at 4 o'clock on a Friday afternoon on a long holiday. I would have pummeled them myself, but, it is what it is. Yeah, exactly. Relentless. 100%. Hey, yeah, let's push this before we go out on a long holiday. Great idea. Yeah. So I actually did get an email at 3 o'clock from somebody. I won't mention title or location inside the company, but with this thing that we want this group of people to review and look at and stuff. And I'm like, it's 3 o'clock on a long holiday, and nobody's going to see this. So they'll see it all on Tuesday, but you probably need it by Tuesday, so that's gonna cause a problem. So anywho. All right, so we're gonna start with the boot process. When you turn on, okay, so we're gonna get a little background for those of you who haven't learned about posts and all these things. In the before times, you had to hear your beep. Yeah. Anyway, when you turn on your computer, it begins a self-executing firmware code that is stored in the motherboard ROM, read-only memory. This code performs a power-on self-test or a post. That's why you pick up the phone and call people instead. Wait, Lady Pete, wait. Oh, my phone died. I don't have a charger, and I went on vacation. Damn. Damnity damn. That's unfortunate. Can't get a hold of me. It's a shame. Yeah. So the power on self-test detects available RAM and pre-initializes the CPU and the hardware. Afterwards, it looks for a bootable disk and starts booting the operating system kernel. Oh, no, I'm in my office, Lady P. See, I'm at work, and then I'm not. See, that's my commute. It's like I'm at work, and I'm not. So boom, it's like, sometimes I have traffic when I'm coming back into my office, but, it's normally the cat sleeping in the door, but, the BIOS system, which is the basic input-output system, is being taken over by the UEFI, which is Unified Extensible Firmware Interface. Sometimes I have tripped on a cat. Yes. So my large, chunky boy, he's more of a speed bump than something you run over. So. So the BIOS standard is old and outdated, but simple and well supported on any x86 machine since the 1980s. You can turn off UEFI, and I still think you can use some sort of modified boot BIOS system because this one, because it doesn't have a TPM module, you can actually turn off and put legacy boot, which I'm assuming either it's UEFI that mimics the old legacy, the old BIOS, or whatever. I don't know enough about that. That's some low-level stuff that my friend John could probably teach me about, or Lady P, obviously Lady P. BIOS is old and outdated, but simple and well supported on any x86 machine since the 1980s. UEFI is more modern and more features, but more complex to set up. You're not wrong in your opinion there. There's a lot of things that go there, because now you have not just UEFI, but you have UEFI with TPM, trusted platform modules, which will stop you from running things like Windows 11 effectively for an encryption point of view. Currently, we only provide BIOS support, but UEFI is planned too. If you'd like to help us with this, check out the GitHub issue. Oh. Thanks for the great blog series, really awesome. Do you have any plans for adding UEFI boot? I assume the assembly would be much simpler since UEFI set up a lot of that for you, including preferring a graphical frame buffer to draw upon. As for the UEFI bootloader, I assume Grub EFI could be used to load a kernel from FAT EXT UFS, or perhaps a kernel can be put on the ESP and loaded directly into UEFI BIOS. Let me see if they've actually solved the problem. Let's scroll down here to the bottom. Yeah, it looks like there's, so it looks like as of 2020, maybe they've got a working instance of it. So yeah, I've got keyboard interrupts working on IO APIC, which means that the UEFI prototype now has all the features of the existing BIOS. Okay, so Phil has not updated the documentation here. According to the GitHub issue as of 2020, 2 years later, it looks like it does work. So it will work with the implementation from Rust Dev OS APIC. So you can go and check that out if you are super interested. Still have audio. There it is. Okay, good. All right. So almost all x86 systems have support for BIOS booting. I don't know what else they would have if they didn't have a BIOS and didn't have UEFI. Unless, yeah, I don't know. I'm waiting for Lady P to fill in those. Anyway, including newer UEFI machines that use an emulated BIOS. Okay, so yeah, that my thought earlier was if you enable legacy booting, the UEFI just shuts off a bunch of stuff that doesn't that makes it legacy compatible. There's no actual second BIOS or second system to use. It just UEFI which simulated. Yeah, that makes sense. This is great because you can use the same boot logic across all machines from the last century. This wide compatibility is at the same time the biggest disadvantage of BIOS booting because it means that CPU is put into 16-bit compatibility mode called real mode before booting, so that archaic bootloaders from the 80s would still work. Good Lord. Wow. But let's start from the beginning. When you turn on a computer, it loads the BIOS from some special flash memory located on the motherboard, or the ROM, read-only memory. The BIOS itself the BIOS runs self-test and initialization routines of the hardware, and then looks for bootable disks. If it finds one, control is transferred to its bootloader, which is a 512-byte portion of the executable code stored at the disk's beginning. That's why, so like, that's why you have a boot partition, right? And usually the boot partition is the very end of, or very beginning of the drive, because it has to be within a certain range, right? So it's usually bigger than 512 bytes, though. I think the bootloader I have for my laptop is somewhere around 500 megs. I think that's about the maximum you can have. I don't want to say that. It's not the maximum you can have, but I know that there's a set amount. And, you know, if you only need 512 bytes, you don't need 2 terabytes of boot disk or bootloader space at the beginning of a disk. Most bootloaders are larger than 512 bytes. So bootloaders are commonly split into a small first stage, which fits 512 bytes, and a second stage, which is subsequently loaded by the first stage. Yeah, we're still dragging 286 code, and that's where we wanted to have x86, x88 backward compatibility. So when we first had the 386, which was 32-bit, you'd have to switch to real mode to run 16-bit code from the 286 era, and using that, you run 8-bit code. It seems like they would get rid of the 286 code because you can't do anything like run Windows 11 on a 286 box or a 386 box or a 486 box. I don't exactly know how low you can, like Windows 11 specifically has to have certain things, so I'd imagine if it doesn't have a TPM on it or it doesn't have a UEFI, you're not going to get it. But, I guess that's why you'd want to run Linux on those older bits anyway. You can't even donate them to charity. That'd be wrong to donate that kind of stuff to charity, unless you're just wanting it like a museum or something. The bootloader needs to determine the location of the kernel image on the disk and load it into memory. It needs to switch the CPU from 16-bit to 32-bit protected mode and then to 64-bit long mode. Well, thankfully that doesn't take a long time. Where 64-bit registers and the complete main memory are available. Its third job. Hey, I've got okay, so hey, so did the 386 have a BIOS? And because the person who wrote this said, you didn't have BIOS. So what was before BIOS, right? So its third job is to query certain information, such as a memory map from the BIOS, and pass it to the OS kernel. Okay, yeah, so it has a BIOS of some sort. Yeah, I was trying to remember, like, there was Phoenix, AMI, there was the third one, I think, Megatrends is there. There was at least 2 that I remember. Phoenix, I'm actually closing my eyes and I can see myself sitting in high school at the computer that I was using for typing class when I would copy somebody else's assignments onto my disk because I couldn't type for shit and I just wanted to play games. Yeah, I'm seeing the American Megatrends because it would drop and then bounce back up and then it would load everything on the screen. Sorry for those of you who don't understand. You have to be there. So, writing a bootloader is a bit cumbersome. You think? Yeah, the first computer my mother got me, that was mine and not the one that we used for my grandfather, was 8088 with a turbo button on it. I think we've talked about it maybe once or twice here on the stream. Had 2 5.25-inch floppies, no hard drive, 360K memory. Ran DOS 622 really well. Started on 401 and then managed to upgrade to DOS 622. That was back when an OS could fit in like 5 meg or less than 5 megs. And it was actually usable. Now we can't put a kernel in 5 megs or like 1.44 meg. All right, writing a bootloader is cumbersome as it requires assembly language and a lot of non-insightful steps like write this magic value to your processor register. Insert magic here. Therefore, we don't cover bootloader creation in this post and instead provide you a tool named boot image. Yes. Yes, boot image. Yes. Cargo install boot image. 5 megs. You could put an I missed the 5 1/4 floppies were like 360K, and you only needed one disk to run MS DOS. So yeah, it was in less than 360K. All right, so yeah, we just run cargo install boot image, and that will pop up in here real good. Therefore, we don't cover bootloader creation in this post and provide a tool automatically. Oh, if you're interested in building your own bootloader, stay tuned. This set of posts on this topic is already planned. Wow, okay. Multi-boot standard. Yeah, I actually have multi-boot on this box because very stupidly I decided, well, let's see if we can run Ubuntu again. Maybe something has changed. Maybe I'll be able to use this stuff to do streaming on, and then 25 man hours later, I'm like, nope, what's the definition of insanity? It's doing the same shit over and over again, expecting a different answer. And so I've, back on this. Oh yeah. Hey, LinkedIn Live folks. Appreciate you hanging out if you're here. To make a kernel multi-boot compliant, one just needs to insert a so-called multi-boot header at the beginning of the kernel file. This makes it very easy to boot an OS from Grub. However, Grub and the multi-boot standard have problems. They only support 32-bit protected mode. This means you still have to do the CPU configuration to switch to 64-bit long mode. They're designed to make the bootloader simple instead of the kernel. For example, kernel needs to be linked with an adjusted default page size, because Grub can't find the multi-boot header otherwise. Another example is that the boot information, which is passed to the kernel, contains a lot of architecture-dependent structures instead of providing clean abstractions. Both Grub and multi-boot are only sparsely documented, that's for sure. Grub needs to be installed in the host system to create a bootable disk image from the kernel file. This makes development on Windows or Mac more difficult. Because of these drawbacks, we decided not to use Grub or the multi-boot standard. However, we plan to add multi-boot support to our boot image tool, so it's possible to load your kernel on a Grub system too. If you're interested in writing a multi-boot compliant kernel, check out the first edition of this blog series. So there you go, if you want to go check that one out. So yeah, minimal multi-boot kernel. Okay. So if you want to, grab yourself a bottle or two of wine and, sit down and crank out a minimal multi-boot kernel, what's that? Oh, that's nice. Very good. The framing came back, yeah? Okay. My good wife, Dr. Brake, was showing me her framed doctoral sheepskin. So yeah, here's how to do a first edition of how to create a multi-boot kernel. And so, all right, because of these drawbacks, okay. So UEFI, we don't provide UEFI support at the moment. Oh, thank you, Relentless. Streamer said congratulations. We got it back in, it was like a year ago, February. So yeah, she graduated with her EDD, her doctor in adult education. UEFI, we do not provide UEFI support at the moment, but would love to. If you'd like to help, please tell us the GitHub issue. I think we've already looked at this. Let's go see here. Is this the one we were talked about already? Yes. Okay. So yeah, they already have that. Phil just hadn't updated the documentation here. So minimal kernel. Now that we roughly know how a computer boots, it's time to create a minimal kernel. Our goal is to create a disk image that prints a hello world to the screen when booted. We do this by extending the previous post's freestanding Rust binary. Chips and Technologies had one. It was a little less common than Award. Oh, Award, yes. Award was the other one. Award, AMI, and Phoenix. They were I think those were the three that I remember seeing. Award was the other one, yes. Yep. my first computer also was monochrome, so everything had to be done with ASCII art if I wanted to play like graphics games. So like BASIC and GW Basic and those. We roughly know how a computer boots. It's time to create our own minimal kernel. Our goal is to create a disk image that prints Hello World. Yes, as you may remember, we built a freestanding library through Cargo, but depending on the operating system, we needed different entry point names and compile flags. That's because Cargo builds for the host system, i.e. the system you're running on. This isn't something we want for our kernel because a kernel runs on top of, example, Gratis, Windows. Does not make much sense. Instead, we want to compile a kernel for a clearly defined target system. And we actually did create a fake system, which I believe was that an ARM system? No, Thumb v7 EM, none was the architecture. So it was pretty much architecture agnostic or OS agnostic. Installing Rust nightly. Rust has Rust book explains the difference between these channels really well, so take a minute and check it out. For building an operating system, we'll need some experimental features that are only available on the nightly channels. Oh, crap. This is where we're going to go into problems. 5 years ago, the nightly version of Rust probably has that. Now, they're probably standard. So we'll... Okay. This is where... Damn. The minute I started noticing the lack of updates on the documentation for things that have been fixed or worked on and completed, I was starting to worry. So, well, hopefully we'll be fine. Hopefully these things are in the nightly mode because we're about to make it Rust up override set nightly. It allows you to install nightly, beta, or stable compilers side by side and makes it easy to update them. With Rust, we can use a nightly compiler for the current directory by running rust up override set nightly. Alternatively, you can add a file called rust toolchain with the content nightly to the project's root directory. You can check that you have a nightly version installed by running rustc version. The version number should contain nightly at the end. The nightly compiler allows us to opt into various experimental features by using so-called feature flags at the top of our file. For example, we should enable the experimental ASM macro for inline assembly by adding, whiz-bang feature ASM to the top of our main RS. Note that such experimental features are completely unstable, which means that future Rust versions might change or remove them without prior warning. For this reason, we will only use them if absolutely necessary. Okay, let me go see. Rust feature. What was the thing I was wanting to look for? Rust. Okay, feature ASM. That's what it was. All right, feature ASM. Okay, so as of tracking issue for this feature 72016. So you can add ASM related inputs and outputs. Okay. We are going to give this a shot. So we're going to whiz bang feature ASM. Technically, I should probably also do the, where is it at? rustc override set nightly. Okay. Well, we'll see. All right, so we're downloading and updating our doc, our installation of Rust to go to the nightly build, as you see down here on the bottom. We're grabbing new things like Rust docs, rustdid, rustc. But what it's doing is I think it's updating to the 2023 version, whichever version I've got, 1710 or something like that. So we will see what happens. 174 nightly. All right, so we have the latest version as of August 31st with this. I believe this is part of the commit hash. So you can go in and check. I think I think this is, for, don't quote me if I'm wrong here. Somebody can tell me, but I believe that this is probably the first part of the commit hash because so many numbers it's going to be nigh impossible to make that different because of collisions or what have you. So these are like the first 8 digits of the hash, I believe. If anybody knows any differently, let me know. Because they're not going to show the entire hash. 256 straw hash or what have you for commit messages. They'll show the first 8 or the last 8 or something like that. It's just for brevity purposes. All right, so alternatively, you can add a file called Rust toolchain with content nightly to the project's root directory. Okay, I've already done all that. All right, and then we do Rust C -- version. All right, so 174 nightly. Yep, exactly. All right, so we're gonna give that a shot. Now, I cannot guarantee, because this is a 5-year-old document, that this is going to work exactly as the book is from here on out, because there is a bit of a divergence. So I did add feature ASM to our main RS. You can see it right there. Let me go and look up number 2. Okay, and close that and close that. All right, so interesting. So number 2 does not. Let me scroll back up to the top here, make sure I've got the right one. Yeah, post 2 branch. So I don't see the feature ASM stuff that is being mentioned in the main RS file. So remove rlibc and use compiler built-in's mem feature. I'm hoping to God. Okay, so yeah, we're already gonna run into some issues, I think. So there's the no mangle. Yeah, the fact that feature ASM appears to have been removed means at some point, as of 3 years ago, let's go look at the history real quick. Panic handler, no std, no main attribute, add dependency on rlibc. External crate rlibc. Okay. Okay, so I'm just checking the. Okay, so there's the func main. Just trying to see if and when that got removed because it's not in the latest version. Add no std attribute. Okay, so that's okay. So all of these things are good. Okay, so no mangle. Okay. Yes, no main, no std, func main. Okay, so what we know is at some point either that was not added at all or they didn't. It wasn't needed. So. Oh, wait a minute. Maybe I'm reading too much in this. It says, for example, we could enable the experimental ASM macro for inline assembly by adding this. Note that such features are unstable, and for this reason, we'll only use them as absolutely necessary. So it sounds like we didn't need to add ASM in this list, which is why it's not in the file at all. So I'm guessing if you need that, then you add that. So. This is an example of me reading too far ahead and not catching all of the nuance, for instance. So I just assumed I would have to do this. And it says you can use a nightly compiler for the current directory. So we could. Should we have? I don't know that yet. So if we run into issues, I'll put it back to standard, stable, not nightly, because nightly is going to be might be super sus. So we'll see what happens. Cargo supports a different target system through the target parameter. We used that a little earlier when we compiled our stuff with a specific target method. Where is that at? There it is. We set cargo right down here at the bottom. You see cargo build, and then we set a target. So if we wanted to build this target by a different OS or what have you, then we do that. And we did that here with like an agnostic version, so that we didn't have a specific operating system. No clear vendor, right? So Rust supports many different language target triples, including ARM, Linux, Android ABI, or EABI for Android, or WASM32 unknown for WebAssembly. For those of you helping me or watching me fail through the game development one, we had to learn a little bit of WASM. We had to learn a little bit of JavaScript at the same time, which is, I think, ultimately why it failed. I wasn't trying to learn Rust. I was trying to learn Rust and WebAssembly and JavaScript. So that was a recipe for disaster. For our target system, however, we require special configuration parameters. Example, no gratis, no underlying OS. Because obviously we want this to be the OS, right? So none of the existing target triples fit. Fortunately, Rust allows us to define our own target through a JSON file. For example, a JSON file that describes x86 unknown Linux GNU looks like this. So we have an LLVM target, data layout. That's interesting. So here's architecture. The endian is little. Pointer width 64 being the bits, I'd imagine. C integer width is 32 bits. The OS is a Linux of some sort, give or take. Executables, true. Okay, so I'm hoping these will be explained as we go down here. Linker flavor, we're going to use a GCC type linker. Pre-link args, M64. M64, so it'll be 64-bit something. Make 64-bit make, maybe. More stack, false. I don't know what the more stack is, but it sounds like it's somehow to do with memory or whatever. Most fields defined by LLVM generate code for that platform. For example, the data layout field defines the size of various integers, floating point, pointer types. And then there are fields that Rust uses for conditional compilation, such as target pointer width. Third kind of field defines how the crate should be built. For example, pre-link arg field specifies arguments passed to the linker. We also target x64 systems with our kernel, so our target specification will look very similar to the one above. Let's start by creating x64 blogos.json file. Choose any name you like with common content. All right, so they removed a few things. No OS, right? Executables, true. No linker flavor, because obviously the compiler may be different depending on what exists on the system. No pre-link args. No more stack. C width, arch, data layout, and target. Okay, so the only we stopped at OS and execute. So we stopped right here. These bits. So we don't 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so no linker flavor, no pre-link args, and no more stack. And then from those, everything else is the same, with the exception of the OS, we've specified none. Okay, so that makes sense. All right, note that we've changed the OS and the LLVM target, right? Oh, right, and the LLVM target, so unknown and none, right? And the OS field to none because we'll run on bare metal. We add the following build-related entries. So linker flavors ld.lld, link, okay. Instead of using the platform's default link default, something like that, which might not support Linux targets, we use the cross-platform LLD linker that is shipped with Rust for linking our kernel. And then panic strategy is abort. So when in doubt, abort, right? So basically, when in doubt, abort. This setting specifies the target doesn't support stack unwinding on panic. We talked about stack unwinding. Lady P was kind enough to give us the definition of that earlier in the stream. So if you're showing up in the middle of the stream right now, you'll have to go back and watch the VOD to catch part 1. So instead, the program should abort directly. This has the same effect as the panic abort option in our cargo toml file, so can remove it from there. Note that in contrast to the cargo toml option, this target option also applies when we recompile the core library later in this post. So even if you prefer to keep the cargo toml option, make sure to include this option, disable red zone true. Okay, so let me figure out where we're putting scroll back up because I want to see where we're putting that at. Okay, so we're adding the target spec file inside the blog OS. Okay, so that would mean we need to put it here in the blog OS link. Okay, so I'm gonna new file. We're going to call it x8664 blog underscore OS JSON. Okay, whoops. Rename JSON. Okay, so, and then we'll add, eventually, I guess they'll want us to add all of these things. So here's the x64 unknown none, the data layout, which is interesting. I'm hoping at some point it'll go through and explain to us this, other than this is just a random value you're going to insert into your kernel, like Phil had mentioned. x86, little, 64 for a pointer width, cint 32. All right, Relentless. Have a good weekend. Thank you for hanging out with us, and keep the faith, bro. You'll get there. All right. Love you, man. OS none, executables true, linker flavor LD, LLD, linker rust LD. No problem, man. It's all right. Panic strategy abort. So when in doubt, die. Basically on the panic strategy, and disable red zone true. And then we're going to add certain processor specific things like MMX, SSE, which are indicative of, back in my day, not all of the same CPU instructions were available in Linux and AMD. Way back in the day. And so, or they were less mature in AMD than they were in Intel. Now I think pretty much they're parity, with the exception of certain things, or in this case, like manufacturing or whatever. I would say, nope, I'm not even going to say. So yeah, there were differences at one time. Now the CPU features are pretty much, I think, like right there. We're obviously. We may talk about this later on in this chapter, but these are probably ones that are specific to both Intel and AMD processors. So if you're trying to make this happen and boot on an AMD or Intel box, this will work. Anything x86-64. Okay, so scroll back down. All right, so we're going to, we got to this point. Okay, yeah, so disable red zone. We're writing a kernel. We need to handle interrupts. To do that safety, we need to disable a certain stack pointer optimization called the red zone, because it would cause stack corruption. For more information, see our separate post about disabling the red zone. Okay, so there's a specific area about red zone stuff. Did not know about red zone. Oh. There's pictures even. So this is all about the stack, right? Okay, so optimization in System 5 ABIs. Wow, application binary interface. So there we go. Y'all can go check that out. I'm not Canadian. I just like saying out because Canadians are awesome. All right, and then we'll need to disabling. So these features fields enables or disables target features. We disable the MMX and SSE features by prefixing them with a minus and enabling the soft. Oh, right, minus. It's not. It's not like in Linux where sometimes you put a dash and then put a switch or something. So minus means duh. Okay, that makes sense. And then we'll do soft float feature by prefixing it with a plus. Note that there must be no spaces between different flags, otherwise LLVM fails to interpret the feature's string. Okay. So MMX and SSE features determine support for single instruction multiple data, SIMD, or SIMD, which can often speed up programs significantly. However, using the large SIMD registers, I'm going to assume a silent D or a very less accented D. It registers in the OS kernel leads to performance problems. Well, we want definitely a performant kernel, God, because, if our 20K kernel doesn't load in half a microsecond, then we're just not doing well. The reason is that kernel needs to restore all registers to their original state before continuing an interrupted program. This means that the kernel has to save the complete SIMD state to main memory on each system call or hardware interrupt. Since the SIMD state is very large, 512 to 1600 bytes. Okay, and interrupts can occur very often. These additional save restore operations harm performance. Didn't know that. All right then. To avoid this, we disable SIMD for our kernel, not for applications running on top. Okay, because you want your kernel to be faster. For your applications, you would enable this. That makes sense. Problem with disabling it is that floating point operations on x86 64 requires SIMD registers by default. To solve this, we add the soft float, which emulates all floating point operations through software functions based on normal integers. All right. So we put it together. Our float looks like this. So we have executables, we have the linker flavor, we have the linker, which is a Rust LLD. The panic strategy is abort. Disable red zone is true, and because we want to not corrupt the stack, and we're going to disable some features. So when I assumed all these features were ones we're going to be enabling, but this little dash here and this little dash here means we're disabling that, and then we're enabling the soft float as per earlier. So to save myself some time, I'm going to cheat and copy paste, only because I feel like the person does a good job of explaining this, so I didn't have to worry about that too much. All right, building our kernel. So we're going to build our kernel now. Oh, and I'm going to save this here. Doink. There we go. It is now, 4:20. Let me see. Save that. Make sure we've got that. And we'll save that again. All right. Compiling our new target will use Linux conventions. Even the author says, I'm not quite sure why. I assume it's just LLVM's default. So the other thing is it's good that that Phil is using LLVM, which is supposed to be, well, it's supposed to be. My understanding when I was using OpenBSD was that it was a better compiler overall. The difference is GCC supports a number of programming languages while LLVM isn't a compiler for any given language. LLVM is a framework to generate object code from any kind of source code. Interesting. LLVM produces code that is comparable or faster than GCC most of the time. This is in part thanks to the modular design of the compiler, which allows for easier implementation of different optimization techniques. Here you go. If you want to just, get after it all day and read about compilers and performance of compilers, there you go. You can't go wrong with that right there. That's some tasty sleeping reading right there. You poke around on that. I have a Medium account, but it's been a minute since I've logged in. So yeah, it's gonna give me some error messages. Yeah, CLang is mainly used to provide performance superior to that of GCC. This is probably another holy war, so your mileage may vary, your use cases may vary. So just, significance of a good compiler. So yeah, there's a whole big thing here. You can go ahead and read that if you'd like. All right, so compiling for our new target, we use Linux conventions. This means we need an entry point named start, as described in the previous post. So we talked a little bit about that. We have to create the insertion point in the memory because we don't have a main. We don't have func main, which would be where the starting point is. So without a starting point, something else. You have to create the point. You have to create the starting point of where it goes. All right. Note that the entry point needs to be called start regardless of your OS. Well, that's helpful. All right. So I'll pull this down a little bit. Yeah, this stream actually ended up a little better. Let me, I'm going to put myself right here. Sorry, y'all. I'm making sure everybody can see things as I'm going. All right, so we have no stand, no main, core panic info. This function is called on panic, so we have loop infinitely. Phil has reversed the mangle and the panic handler for some reason. Not sure why. I don't think it matters much because it did build successfully, without those. What's this here? Anyway, note that we now build the kernel for our new target by passing the name of the JSON file as a target. Oh, okay. Very good. All right, so as you can see down here at the bottom, I'm going to highlight it there. Now you have to, my OBS screen is really tiny, so I'm just making sure that that's big enough. It says cargo build target, and it's waiting for me to put a target in. So I put target, and I'll be x86. If I can hit tab for autocomplete, there you go. Oh gods. Yeah, let's un-F that. I don't know why I put a comma there, but it shouldn't have been comma. And I'm going to back that ish up. There you go. All right. So what you see is cargo build target in the same directory x86 underscore 64-blog underscore os dot JSON. So it's going to take the previously created bits and it's going to put them in properly. I don't know what the data layout is. Did it mention the data layout? I want to see if it has data layout. Control. Oh, no, that's not what I want. Control F. Data layout. Data layout defines the size of various integer, floating point, and pointer types. Oh, okay, there you go. So then there are fields that use conditional compilation, such as pointer width. All right, so yeah, for example, so that's not for example. It actually does define integer, floating point, and various pointer types. So E minus dash M E dash I64 64 dash F80. Interesting, F80. Why does that sound familiar? I can't remember. Something's jogging my memory about F80. Interesting. Like FE80? FE80. That's what I'm thinking of. FE80. What is that? Oh, okay. So, yeah, it's a valid default gateway IP address. Sorry. I don't know why that came to me like that, but FE80 : 1 is, yeah. Okay. FE80s, yeah. Okay. Sorry, complete non sequitur. So, yeah. All right, so we'll scroll back down. All right, we're going to build our kernel using this target, and then, this is, can't find crate for core. All right, so the one thing that bugs me about books like this is they want you to do something, and then it's going to error, and you're like, oh, okay, so what did I do wrong? Oh, no, it fails because it's going to do that. So I'm not going to build with this target just yet. The error tells us the Rust compiler no longer finds the core library, obviously, because we've took out all of the all of the libraries, all of the types. This library contains basic Rust types such as result, option, and iterators, and is explicitly or implicitly linked to all NoSTID crates, OSTD crates. The problem is the core library is distributed with the Rust compiler as a pre-compiled library, so we don't have any libraries, so we're going to have to create these things. It's only valid for supported host triples. Okay, so we don't have those libraries for Linux because we're not building specifically for a specific type of Linux, right? We have an unknown, so we have to decide how we're going to handle certain things for certain OSs in this case. This is where build std feature comes in. It allows to recompile core and other standard libraries on demand instead of using a precompiled version shipped with the Rust installation. Now, obviously, when this was written back in 2018, this feature was very new and still not finished. So it might be different. This may be where everything starts to blow up, and we'll see what happens. So this is where the standard feature comes in. We're going to recompile core and other standard library crates on demand instead of using precompiled versions. It's unstable. Use this feature. We need to create a local cargo config at cargoconfig.toml. The cargo folder should be next to your source folder, which is okay. I'm going to need to create a new folder. Maybe? All right, one sec. I don't want to recreate a folder if it actually does exist already. So blogos cd.cargo. Okay, so there isn't one. mkdir. This is probably the easier option just to do that right there. Okay, so we created a cargo folder. There it is. And we're going to create a file called config.toml. The cargo folder is being we're going to create this folder. So we're already in unstable, so that makes sense. Cargo, new file, and we're going to cargo it config.toml. And we're going to paste this bad boy in. So it's unstable, build std. We're going to build core, and we're going to build compiler built-ins. This tells the cargo it should oh wait, we got a green light down here. Okay, so the unstable build std config key requires at least the Rust nightly from 2020, July 15th. So we have that. Obviously, we're so far in the future that, you know, again, that's why I said this may or may not work, depending on how, you know, maybe we don't need nightly. Maybe these are already included. I'm hoping that they haven't been removed for some reason, so we'll find out once we try to build this bad boy. All right, so let's hit that and save. We're going to save that. We're going to save everything just to make sure we don't screw anything up when we try to get the build in. After setting, everybody got quiet all of a sudden. If you're following along, that's cool. If you have any questions, please let me know. I kind of got in my own head here for the last 15 minutes or so. I just want to make sure that everybody's cool with what's going on. I'm doing a bit longer today because I started a little earlier today. It helps when you don't start at 3:30, you start at 2:30. So, yeah. All right, after setting the unstable build std, which we did in config.toml, oh no, I said it. Oh yeah, unstable. Okay, the unstable build standard. Okay, so it's unstable and then build standard config key and installing the Rust source component. Do not sure we did that. Did it mention Rust source somewhere up here on top? All right, double check. Control S, Rust src. Okay, so I did not finish reading the end of the statement here. Rust up component, add Rust source. So we're going to pull down Rust, basically, it sounds like. Downloading component Rust, installing component Rust, done. Okay. All right. So after setting that and installing Rust component, we can rerun our command. All right, so I'm going to run this bad boy now. So, all right, so let me just make sure I get the right bits here. Copy. And just for everybody's edification, in about 28 minutes, I'm going to be taking off. Have stuff in the sous vide that I'm going to barbecue or grill up tonight. So whether I'm done with this section or not, and it looks like, according to my slider here, I'm only up at, I'm only about a quarter of the way through this. I mean, we've got a ton of stuff to go through. So, oh wait, is that just? Oh no, so this is, wait, so maybe we're almost done. Okay, so there's comments. There's a lot of comments. There's a lot of comments on this chapter. Oh crap. Oh God. Oh shit, I'm not liking this at all. Okay, well, let's think positive. Let's not... Okay, so anyway, all right. Oh, it took me back to where I needed to be. All right, so we're going to run this thing. Cross fingers, y'all. Cross eyes, fingers, whatever. Come on, you rat bastard, get it. Come on. Come on, get it now. Get it. Build faster. Be done. I got 32 cores in this mother. Come on, make it happen. And 128 gigs of memory. Oh my God. Wow. Okay, so okay. 3, 4, 5, 580. We're going to probably, okay. 41 seconds. Well, that didn't take very long. I'm sorry. Yeah, I was looking to see it. I won't lie to you. When it was compiling, of the 32 cores that I had, it went from, I've got a standing at about 12% CPU. It took it up to about 35%. So that's not bad. It's not bad. Okay. All right. It didn't error out. I'm cautiously optimistic right now. So, all right. So it says, we see that cargo build now recompiles core, Rust C std workspace core, dependency of compiler built-ins and compiler built-ins plugins for our custom target. So here's compiler built-ins. Here is std workspace core 199.0, and we downloaded the compiler plugins. We built core v0.0.0. Oof, crazy. Okay. Memory-related intrinsics. The Rust compiler assumes that a certain set of built-in functions are available for all systems. Note, most of these functions are provided by compiler built-ins crate that we just recompiled. However, there are some memory-related functions in that crate that are not enabled by default because they are normally provided by the C library on the system. These functions include memset. So I think Sakura mentioned a little earlier, we're using the Rust or the C crate or whatever. So it definitely sounds like, according to this, we're not. These functions include memset, which sets all bytes in memory block under a given value, memcopy, which copies one block to another, and memcomp compare, CMP. MemCMP, which compares two memory blocks. While we didn't need any of these functions to compile our kernel right now, they will be required as soon as we add some more code. When copying structs, some memory structures, I'm thinking. Since we can't link to the C library of the operating system, we need an alternative way to provide these functions to the compiler. One possible approach could be to implement our own memset function. Yeah. Man, that... Yeah, okay. And apply the no mangle attribute to them to avoid the automatic renaming during compilation. Exactly. However, this is dangerous. because the slightest mistake in the implementation of these functions could lead in undefined behavior. For example, implementing memcopy with a for loop may result in infinite recursion because for loops implicitly call the into iterator into iter method, which may call memcopy again. So it's a good idea to reuse existing well-tested implementations instead. Also, you could, try to write your own and cause security issues or something like that. Use the devil that you know instead of the devil you don't know. Says, fortunately, the compiler built-ins crate already contains implementations for all the needed functions are just disabled by default. It's not collide with the implementations from the CLIP. We can enable them by setting Cargo's build-std features flag to compiler built-ins mem. Like the build-std flag, this flag can either be passed on the command line as a Z flag or configured in the unstable table in Cargo config toml file. Since we always want to build with this flag, the option in the config file makes more sense to us. So we're going to add these two options, or we're going to add this option to our config.toml. So we'll put it before. I don't know if order makes a difference. It sounds like it would make a difference. You'd want to build the mem bits in, and then it'll, build the other bits on top of it. So it's going to build the mem portions, and then it will build the compiler built-ins overall and leave those enabled. Maybe that's what. Maybe it's like it builds in order, right? Support for compiler built-ins mem feature was added only very recently, 5 years ago. So you need at least 3 years. Okay, 2020 September 30th. So we're coming up on the 3-year anniversary for having compiler built-ins mem feature built in. So there you go. Behind the scenes, this flag enables the mem feature for the compiler built-ins crate. The effect of this is that the nomangle attribute is applied to the memcopy, etc. implementations of the crate and makes them available to the linker. Okay. With this change, our kernel has valid implementations for all compiler-related functions, so it will continue to compile even if our code gets more complex. All right, so that's cool. All right, let me go ahead and save that just in case. There we go. Set a default target. Interesting. Oh, well, that's awesome. Yeah, that's a good idea. So we don't have to, it's almost like when you're doing what's the name of that thing? Ansible or Chef cookbooks, for instance. You're wanting to build the same way every time, and it's like you might hit cargo build, and it's like, oh crap, I didn't build with the right, I didn't add the Z function, or I didn't set the target function, or I did, oh crap, okay, I did this. Why is this not working? Or oh, that's because I didn't do blah. Having it all in one easily recognizable, and it will always call that configuration file. You're always going to get the same build every time, which is great. It's great to have that sameness to be able to recreate, and makes it easily exportable. So if I wanted to be lazy and give this to somebody who's learning this with me, I could just say, oh, well, just take these files. It'll build the same way on your system within reason. Obviously, they have to have their stuff set up similar to mine. They'd have to have the same night, Rust nightly, et cetera, et cetera, et cetera. Tells Cargo, yes, use this target when not explicit target argument is passed. So command line overrides everything. Otherwise, it's going to use the config file. This means we can now build our target with a simple cargo build. Right. For more information on cargo configurations, check out official docs. We will now build our kernel for bare metal with simple cargo build. However, our start entry point _start, which will be called to the bootloader, is still empty. It's time that we output something from the screen from it. Oh, very cool. Printing to the screen. The easiest way to print text to the screen at this stage is with the VGA text buffer. God, I don't know what that's going to do. It is a special build memory area mapped to the VGA hardware that contains the contents displayed on the screen. 80 by 25 characters, right? It's ASCII text. Yes. These are the exact my monochrome monitor I told y'all about 40 minutes ago with my first computer. Games were, done using son of a crap. Here we go. Yeah, it used these ASCII characters for like NetHack kind of stuff. So they made tunnels using these bits here, and I was a character that looked like this up here, and all the GW Basic games would use these characters from the VGA buffer, which I didn't know that at the time because I was 12, 13 years old. So there you go. I would imagine even NetHack uses similar. I think they've expanded it out to the other Unicode characters, but yeah, these definitely look very similar to some of the stuff I've seen way back in the day. We will discuss the exact layout of the VGA buffer in the next post while we write a small driver for it. Oh, great. We're going to make video drivers, y'all. For printing Hello World, though, we just need to know the buffer is located at address 0xb8000. 0xb8000. Do. Sorry, that's not the right. That's not the right one. And each character cell consists of an ASCII byte and color byte. So in this case, the implementation looks like static hello U8. So I'm assuming that's like UTF-8, maybe. B hello world. I'm assuming B is bold. We'll see. I have no idea. Implementation looks like this. All right, so first we cast integer B8000 into a raw pointer. Then we iterate over the bytes of the static hello byte string. So static hello byte string, right? This is the byte string. Oh, sorry. Damn it. This is the byte string, I think. Yeah, right there. We use the enumerate method to additionally get a running... Oh, let me shrink this down a little bit so I can catch all this in here. We use the enumerate method additionally to get a running variable I. So where's the I? Okay, so here's the for loop that mentioned earlier that if we don't do the for loop right, it will, call this one thing that will just cause us to, go completely pear-shaped. So we use the offset method to write the byte string and the corresponding byte color. 0xb is light cyan, so it's a light blue color, which actually is very similar to the color that I'm using to highlight this with, as a matter of fact. Note there's an unsafe block around all memory writes. The reason is that the Rust compiler can't prove that the raw pointers we create are valid. They can point anywhere and lead to data corruption. By putting them in an unsafe block, we're basically telling the compiler we are absolutely sure that the operations are valid. Note that an unsafe block does not turn off Rust safety checks. It only allows you to do 5 additional things. The 5 additional things are dereference a raw pointer, which I think is what we're doing. Call an unsafe function method, access or modify a mutable static variable, implement an unsafe trait, or access fields of union S. Access union S. Union capital S? Don't know what, let me go down here and scroll and see what unsafe union S is. Unsafe trait. Okay, unsafe union, not union S. Unions. I think they meant unions, but they added the S at the end, which makes that really weird looking. Accessing fields of a union. So there you go. Back that up. And you can go look at that as well. Doink. And doink. There you go. All right. 15 minutes, y'all. Okay, so. So it's in bold, so it makes sense. I want to emphasize that this is not the way we want to do things in Rust. It's very easy to mess up when working with raw pointers. Okay, so yeah, it was the raw pointer thing. Number 1 in the 5 things you shouldn't do. Inside unsafe blocks. For example, we could easily write beyond the buffer's end if we're not careful. Yes, buffer overflows, bad. Bad. Oh, let me double check my audio. Make sure, okay, good. Y'all can still hear me. So yeah, this way we only need, for example, no, wait. We want to minimize the use of unsafe as much as possible. Yes, if we can get away with not using it at all, that's the best. Rust gives us the ability to do this by creating safe abstractions. For example, we could create a VGA buffer type that encapsulates all unsafe and ensures that it is impossible to do anything wrong from the outside. This way, we would only need minimal amounts of unsafe code and can be sure that we don't violate memory safety. This will create such a safe VGA buffer abstraction in the next post. Oh, we will create this safe abstraction in the next post. This is great. I know one of the reasons that I was kind of wanting to use Rust was because I had read that, and those of you who watch the stream regularly know why, but it was like a Windows kernel replacing code with Rust. So yeah, according to them, they are rewriting parts of the Linux kernel in Rust because they want it to be more memory safe. They want to use, they want it to, yeah. So yeah, they said, talking about one of the most complex engineering products on the planet. Our goal is to improve security. You'll see Windows booting with Rust in the kernel in probably the next several weeks or months, which is really cool. So if you're using it like a Windows 11 Insider preview, maybe you might have some of this Rust code in because this was written in April. So it's been 4 or 5 months. So yeah, you may be seeing that now. Let me see, 152,000 lines of code. That's pretty good. They've already rewritten at least 36,000 lines. So in the 4 months, they've probably done another 100,000 lines of code. So yeah, they're wanting to do what they can. What Microsoft won't be doing is replacing the entire 40 years work of C or C++ with Rust, but it makes sense to replace some of that to remove legacy attack surfaces while moving new kernel works to Rust, as is the case with Linux. Recently released 6.1 kernel has Rust code in it too. So, for those of you Microsoft haters thinking, they're doing that, Linux is already doing that as well. So it's good to see that that they're doing their due diligence on both sides of the aisle here. All right, now that we have an executable that does something perceptible, it's time to run it. First, we need to turn our compiled kernel into a bootable disk image. We're going to put QEMU on here. Okay. First let me run cargo build so that I know that I have all of the targets. Oh, wait. Let me make sure I've got everything saved here. Okay. Oh, I didn't add okay, so I need to go look at BlogOS, source, main RS. All right, so we want to add the no mangle bit, a static hello, no mangle. Okay, pattern buffer. Okay. So we're going to add this bit. Damn it. We're going to add this bit here. So this is the VGA buffers, our offsets. We're going to put it between that right there. We're going to close that up. And okay, we get rid of this no mangle here. Okay, so we're matching everything. There we go. So we've got our static hello, no mangle, pattern extern C, and FN start. Okay, we got all those in there, and then we have the panic down here. When in doubt, loop kind of thing. Panic info. All right, we got that too. All right, so Control S. All right, now I've done all that, added all that. Let me just cargo build this bad boy. Okay, so this is where we wait again for another 40-ish seconds. Oh, cool. I forgot. It only compiles the changes, right? So that's cool. All right. All right, so creating a boot image, we'll need QEMU or something similar. Let me see, we need, here we go. We can run the disk image in the QEMU virtual machine or boot it on real hardware using a USB disk or stick. To turn our compiled kernel into bootable disk image, we'll need to link it with a bootloader. As mentioned in the previous section about booting, the bootloader is responsible for initializing CPU and loading our kernel. Instead of writing our own bootloader, which is a project on its own, we use the bootloader crate. This crate implements a basic BIOS bootloader without any C dependencies, just Rust and inline assembly. For our booting our kernel, we'll need to add a dependency. So we'll need to add under cargo toml bootloader 0923. Now, it's again 5-year-old, so we're going to use the bootloader version that they're suggesting in here. Obviously, bootloader equals might be 1.0 or something right now. So we're going to use the one that we know works. It's known good, or at least it's known-ish good. So I just actually under dependencies, so I just put it right there. All right, there we go. Adding the bootloader as a dependency is not enough to actually create a bootable disk image. The problem is we need to link our kernel with the bootloader after compilation, but Cargo has no support for post-build scripts. To solve this problem, we created a tool named boot image, which first compiles the kernel and bootloader, then links them together to create a bootable disk image. To install the tool, go into your home directory or any directory outside your Cargo project and execute the following command in your terminal. What? To install the tool, go into your home directory or any directory outside of your Cargo project. Okay, so if I go cd ... cd rust. So if I go cargo install boot image. So far so good. I'm hoping that was the right place to put this. Okay, we got about 5 minutes, y'all. It's done. Okay. So boot image 10.3 is the latest one. It took 23 seconds to run, or almost 24 seconds. For running boot image and building a bootloader, you need to have the LLVM tools preview rustup component installed. You can do so by executing rustup component add. Okay, I'm assuming I have to be back in the directory that I want to be in, right? So cd rust blog and wait, okay. You can do so by executing rustup component add LLVM tools preview. Okay, so that's running, so it's going to run and install LLVM tools. It's downloading. That worked. Okay. Add, right? Okay, after installing boot image and adding that, you can create a bootable disk image by going back into your Cargo project direct. Oh, God. Okay. cd ... Okay, so yeah. Okay, so I just did this outside of the. We'll see if it screws the pooch. Hey, Digital Warhead, thank you for subscribing. Yeah, 18 months. What? All right, so we're gonna do that, and now I'm gonna go cargo boot image. Cross fingers, y'all. Oh, it's gonna work. It's gonna work. Okay, so far so good. Okay, I'm really looking. I'm trying to build an operating system from Rust, their Digital Warhead, and technically I'm about to be done because I have to go cook dinner for my lovely family. So I'm trying to finish this up. Yeah, I can't. Oh, man, I really want to. Yeah, there's a lot here, so I'm thinking I need to hang this up for now and maybe come back to it later in the... Oh my God, it worked! Yeah, break OS, exactly. Yeah, 100%. Yeah, bully. Excellent, yes. Okay, so that built. The built. Interesting. That did in fact build. So it says recompiles our kernel using Cargo build, automatically picks up any change you make. Afterwards, it compiles bootloader. Like all crate dependencies, it's built once and then cached, so subsequent build will build faster. Finally, boot image combines bootloader and your kernel into the bootable image. After executing it, you should see a bootable disk image named boot image blog OS bin, right? Yes, right there. Created boot image blog OS bin right there in my GitHub drive, or on my Google Drive. And you can boot it on a virtual machine or copy to a USB drive to boot it on real hardware. Note, this is not a CD image. It has a different format, so burning it to a CD doesn't work. How does it work? It compiles our kernel to an ELF file or executable unlinkable format. I only did that because I hovered over and saw the Wikipedia thing there. It compiles the bootloader dependency as a standalone executable, and it links the bytes of the kernel ELF file to the bootloader. When booted, the bootloader reads and parses the appended ELF file, and then it maps the program segments to virtual addresses in the page tables, zeroes the BSS section, and then sets up a stack or a memory stack. Finally, it reads the entry point process, our start function, and jumps to it. Okay, I have to stop, y'all. I apologize that we're not going to be able to see this go to Hello World and QEMU. I've been on for 2.5 hours, which is normally an hour longer than I normally do, but I actually was excited that it worked, right? So I'm going to go poke around and see who's online right now this time of day. Break. I've started following a few more people in InfoSec recently. Let's go see what we got. Let's see. T-Pain is on. Strager. Strager's always good. Make Your Deck. Leak Beats. Chill Hop. 6-7 Radio. Relax Beats. Strager. Looks like Strager's online. Yeah, thanks, Digital Warhead. Appreciate that. Let's go raid Strager. And yeah, hope everyone has a good holiday, good weekend. I may be on at some point this weekend or Monday. But yeah, good to see y'all. We'll continue on with the rest stuff because so far it's working well. Feel free to subscribe or get on the VODs. Tell a friend if you found value in this. So we're going to go and raid now. So have a good weekend. Otherwise, I'll see you when I see you. Bye, y'all.